Hi everyone. Let me move this. I'm Matt Baumgartner. I'm a postdoc at Eli Lilly and Company. I did my PhD in computational biology at the University of Pittsburgh under Dr. Carlos Camacho. Um, and so I can skip through most of this because we all know about it. But so getting into, I'm mostly going to talk today about some of the post-prediction methods that we did, and then if I have time at the end, I'm going to very briefly touch on how we did for this scoring. So for the post-prediction, one of the first things I did was look at all of the structures in the PDB and ended up picking out 3 representative structures that I used as my reference structures throughout this. And so I picked them basically based on diversity. So they're shown here, and mostly the differences are in these 2 helices here. So in this structure, both of these helices are pulled out. So and if you can compare that to say this helix here in 3DCU, where it's pulled in, the binding site is much more close. Sorry. And so these are the 3 structures that I used throughout here, and hopefully I'll get to tell you whether or not that was a good idea. So my post predictions, I submitted 5 different methods. My codes are at the bottom there. So the first one was what was called align close. So I basically generated conformers of the test set compounds and align them using Forge from Crescent to the most similar co-crystallized ligand in the PDB of those 26 structures in the PDB. And then for each of those conformers, minimize and then rank based on the best score. And so I used the Venus scoring function. Next is I did a very straightforward docking procedure using SPINA, which is based on AutoDock Vena, which is a rigid receptor, flexible ligand, Venus scoring function. So it's a very straightforward method. The next is the induced fit docking method from Schrodinger, which I'll discuss in a minute, but it essentially allows flexible receptor side chains and as well as ligand sampling. And then I did binding pose metadynamics, which is another tool by Schrodinger, which allows for rescoring and re-ranking of the input poses using a MD-based method. Finally, I used a kind of manual visual inspection method where after I looked at all of the poses from all of my methods and chose the ones that I thought looked good, and that ended up working okay. So just very briefly, I want to discuss the Schrodinger's induced fit docking protocol in case you hadn't heard of it. So basically, I won't go through this whole thing, but essentially it allows for the side chains to move in the protein, although not the backbone. And essentially what it does is it iteratively samples the ligand using glide and the protein side chains with prime, and does that for a certain number of times until it reaches some criteria. And so in that way you can get poses with allowing for the induced fit docking, the induced fit of the protein. The next thing is binding pose metadynamics. So if you're not familiar with what metadynamics is, so it's a MD-based method where throughout the course of the simulation, a force is added according to some collective variable that you define, so that allows you to sample more space. So in this little animation here, you see an energy landscape with 3 wells where you start in the middle. And throughout the course of the simulation, in the red dot, this added force in blue is applied that helps you get out of that energy well and eventually sample into this lower well here. So this binding pose metadynamics uses the same principle, but what the collective variable is it's a measure of the ligand arms D and the number of contacts with the protein. So the idea is the metadynamic simulation is pushing the ligand out of the pocket using this collective variable, and how hard it has to push is a measure of how good the pose is. And so one thing I want to mention is at the end you just get a score of the input pose you don't get a new pose because you've pushed it out of the pocket. Okay, so for my structure prediction methods, I used a semi-ensemble based method where for my Smino docking, I docked the test site compound to my 3 reference receptors, which I mentioned before, and then took the top 5 scoring poses from the 3 dockings. I did the same thing for the induced fit docking, and so took the top 5 scoring poses across all 5 dockings. But for the metadynamics, I took the top 5 scoring poses from each IFD run, and then rescored those with metadynamics. And then of those 15 poses, took the top 5. So the submitted poses from the IFD are not necessarily the same poses as the poses from metadynamics, although they could be if they were both ranked high. So, all right. So into my results. So overall, the align close method did quite well for as far as identifying poses. My top 1 that were good. The Smino docking methods. So if we just look at the how well he sampled in his top 5 here, the rigid receptor actually did about as good as the induced fit docking, but when you include, but when you rescore the poses from the IFD using the metadynamics, you actually improve, and you get, and we pick up 4 more, and you get 23. So the other final thing is my manual method also did pretty well, which I'll show you at the end, which is nice for me because I thought I knew what was going on for most of these, and it turned out to be correct. So, okay, so overall, my metadynamics method was the 4th place method, followed shortly by my manual method, which chose a lot of the poses. But overall, I was pretty happy with these. The improvement from the IFD poses to the metadynamics poses was very nice. This is something that people have mentioned before, in that the scaffold played a huge difference in this. So most of my methods did well by doing well on the benzimidazoles, but only picked up 1 or 2 of the other ones, which from what we've seen and what Pat showed, I think is pretty consistent. So this table here is huge and busy, but I thought it was helpful for me to kind of understand what happened. So this is basically everyone's best results. So each on the left here is each method, the average RMSD of each method, and then each square is the best RMSD of that pose for that method. And so, as has been mentioned before, basically, most people did well in the benzimidazoles. One thing I would like to hear about is this TOUHI person who submitted this best method, because so they did quite well, but didn't submit poses for all of them. But very, very interestingly, they submitted. They were the only person to get a correct answer for FXR 18. So I'd be very interested to hear what they did. So most people did good on the benzimidazoles, but all the rest of the scaffolds were pretty tough. My little claim to fame is that my metadynamics method was the only one that got the FXR 23 correct, which was nice. But yeah, some of these, like FXR 1, no one was able to get. So so I was looking at some of the reasons why I did poorly. So I looked at FXR 12, which is one of the spiros, and what my conclusion is that the actual crystal structure released afterwards is actually just quite different than any of the structures that I could have used to predict it. And so this kind of shown here some of these reasonably large changes in the pocket. And this was my best pose, which is still not good. So these are the movement of the pocket was quite significant and challenging. So here I'm just briefly showing that. For my metadynamics method, I docked using the IFD to each of those 3 reference receptors, and then took the top 5 across those, which afterwards I can see I shouldn't have done, because using one of these, this 3DCU, only produced 3 compounds, or 3 good poses for 3 of the compounds. So this ensemble method for this, in this case, didn't seem to be a good idea. One other thing I looked at was the binding pose metadynamic score. So each pose you give it gives you a score, and I wanted to see how meaningful is that score as far as identifying high or low RMSD poses. And one thing that's really interesting here is if we just look at this graph here. So this is a graph of the score of a pose and the RMSD of that pose, and they're colored by the scaffold. And so what I noticed is basically if the score is above 0, that's a pretty good indication that it's not a good pose. So there's only one error here in purple. So there is a 96% true negative rate saying if it has a bad score, it is a bad pose, which is useful. So the true positive rate of 69% is not as good, but still nice. I'm just going to skip. Well, let's go through these very quickly. So I was also looking at the differences between the structures that I used to make the prediction and the actual crystal structures released afterwards to see were my predictions correlated with differences in the structure. And in general, for these two, you see this line generally slopes upward, saying more different things that are more different generally give you worse RMSDs. There is one here for this 3O-KH that where the trend is opposite for the benzimidazoles, and that seems to be that the main difference here is this one helix, but it's far enough outside the pocket that it doesn't really, it's not really in contact with the binding site of the benzimidazoles. I'm just going to skip through that. And finally, for my manual method, as I was going through, I took notes saying I think this pose is good or bad or whatever, and afterwards I went to see how good my assessments were, and I was pleased to see that my evaluation of good, bad, or okay, as I wrote down as I was looking at them, correlates quite well with the actual RMSD of the pose. So I just kind of point out visual inspection's still important, and you can get a good idea of if you have an idea of what's going on, you should use that. Finally, I just want to thank the organizers. The pose prediction challenge for this was really quite tough, and this is in kind of a comparison to previous years where at least my methods did really quite well. So it was good to see a difficult challenge. And very, very briefly, I'm going to talk about my affinity prediction. I submitted 5 methods, which I won't go into here too much, but the codes are shown here, which are mostly structure-based methods, but 2 ligand-based methods as well as 2 QSAR methods. And we did okay, I think. My top scoring methods were using the Autodoc Vena scoring function, which is nice because that's quick and cheap. But yeah. Yep.
I just want to let you know you have 1 minute.
Okay, thank you. But the one thing to keep in mind is that all of these methods in the top 27 or 25 or whatever are probably all statistically equivalent. I haven't done actual testing, but that's my guess. So, but it's nice to have several different methods near the top. So, In the end, I just wanted to thank the EU grant that funds my postdoc and Schrodinger for some of the help in the software. And so that's all.